Hi 8th graders, this is Mrs. Barnett here to show you how to calculate rocket altitude. When we launch our rockets, we will be standing about 30 meters from the launch pad. So I'm going to mark that here on the whiteboard. You will be standing looking up in the sky with a tool that's going to help us figure out the angle from where you're standing that the rocket reaches. So we're going to draw a line to show that you're looking up into the sky at the height of the rocket. You are going to measure the angle using this tool when you think the rocket has reached its highest point. Then we are going to use these three positions: the height of the rocket, the launch pad, and you, and we are going to make a right triangle out of them. Here's the triangle that I made using the launch pad, the rocket, and you. Again, you are going to be about 30 meters from the launch pad. And then you're going to record your angle in this triangle. So let's just assume that you have an angle of about 60 degrees. Again, this is the angle that you determined through the tool when the rocket was at its highest point. Our unknown is going to be the height. So I'm going to label that with an H. And now we have enough information to calculate the height of the rocket using trigonometry. So those of you that have had geometry will understand this. And those of you who haven't had geometry are going to want to continue to watch this video. So we're going to start by giving this angle a name, and I'm going to call it angle theta. And according to the tangent function, when you have a right triangle, the tangent, so tan, of the angle theta, which I'm labeling this angle here where you're standing, is equal to the opposite side. And the opposite side from this angle is going to be the height. So the height divided by the adjacent side. And the adjacent side means next to, and that is going to be this distance here, 30 meters. So now we need to rearrange this equation so we have the height alone. So I'm going to multiply this side by 30 and this side by 30, and then that gets the height alone. So now if we rewrite this equation, I'm going to find the height by finding the tangent of my angle theta multiplied by 30. The next step is going to be to find the value of the tangent of this angle and substitute it into the equation. In order to find this value, I need to go to something called a tangent table. So I'm going to go to that table. Again, the angle is 60 degrees. We will need that value when we will look at the tangent table. So here we are at the tangent table, and you can see the tangent of angle 60, an angle with 60 degrees, is going to be 1.7321. Now we're going to substitute in, so now we have height equals 1.7321 times 30. When I multiply 30 and 1.7321, I end up with 51.963. So that means that the height that the rocket reached is about 52 meters. Now I would like you to go to the altitude calculations page in your rocket booklet and complete the 4 practice problems.